Okay, business algebra, let's wrap up 3.2. Another piecewise function we're graphing. F of x equals 2x if x is less than or equal to 2, or negative 3x as x is greater than 2. So again, we'll follow the same steps from last time. We're first going to plot the boundary points. So I need to plug in 2 to both equations. So f of 2, that would be 2 times 2, or negative 3 times 2. That would be 2 times 2 equals 4, negative 3 times 2 equals negative 6. So I have the point 2, 4, and 2, negative 6. These are the two that I'm going to plot with an open circle. So 2, 4, and 2, negative 6. So here we have 2, 4, and 2, negative 6. I have to figure out which one now I need to shade. Again, the equal sign is now with the less than, so I need to find the equation 2x, which was this one, and I need to fill in that circle because that's where the point actually is. And this represents our transition from one function to the other. And now I have to graph the equation 2x and negative 3x. So 2x is a slope of 2 coming out of the point 2, 4. Now normally what we like to do with slope is that's our rise over run. We want to go up 2 and over 1. However, the only direction I can go with less than is to the left. So instead of going up and to the right, I need to go down and to the left to get my line. If you are not sure how I'm doing this, if you take any other point to the left of 2, say plug in 0, then it will give you a point to help you connect the line as well. For the negative 3x, the right side, instead of going up and to the left, negative 3 as a slope would go down 3 and to the right. And we're allowed to go to the right because we're on the greater than side, so down 3 over 1. And so this is the graph of our function. It kind of looks like a guy pushing a lawnmower, something like that. So this is what the function looks like. We're going to skip number 3. 3 is really long and it's probably too hard for the difficulty of this class. And if you see any of these on a test, they're more likely to look like 1 or 2 or somewhere in between the two of them. And the last thing you might see in this class is what's called a greatest integer function. And that's where the function only jumps at whole numbers. So it kind of creates what I call a stair-step function. So, and it's denoted by these double brackets around the function. So f of x equals the greatest integer function of x means I don't transition normally like f of x equals x where I'm constantly going up. Here, I start at 0 and I stay at 0 until I hit 1. And the moment I hit 1, I jump up to the next one and I stay at 1 until I hit 2, and so on and so forth. Until I keep jumping once I reach a whole number. So it kind of creates this stair function. And it also goes down as well. So it creates an infinite stairway to heaven. But you can't buy it in this case. Just wanted you to see what this looks like. I think there may be some multiple choice questions about these types of functions. So you'll just look at values. I won't put it on the test though. And lastly, let's do a piecewise function word problem. The Alabama state income tax for a single person in 2017 was determined by the rule. It's 2 cents for every dollar for your first $500 of income, 4 cents for every dollar between $500 and $3,000 of income, and then 5 cents on every dollar above $3,000, which is what this means in money. Draw a graph representing taxable income. you only make positive money, so we're only going to draw like a top quadrant. What are our boundary points? That means if you make $0, obviously pay 0 tax. So let's look at some boundaries. We have 500, 1,000, 1,500, 2,000, 2,500, 3,000. It says it wants it to 5,000. This is 500, 1,000, 2,000, 3,000, and up to 5,000. Okay, so we have pay $0. So let's check our boundary points. Our first boundary point is at 500. 0.02 times 500 is 10. If we plug in 500 down here, this becomes 0, so it's also 10. So we have the point 500, 10. So here we have the point 510, and this actually, for income tax, this is for both of the 500s. If I plug 500 here, it's 10 plus 0. My next boundary point is 3,000, and it's 110 when I plug it in, because 3,000 minus 500 is 2,500. 0.04 of that is 100 plus 10, and so at f of 3,000, I'm at 110, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and 110. So I have a line here which has a very low slope, and then for the next amount of money, it gets a little bit higher. And then it says it wants it all the way up to 5,000. So what is the f of 5,000? 5,000 minus 3,000 is 2,000. This is 2,000 divided by 20, which is 100. So 110 plus 100 is 210. I don't have enough room on my graph, but safe to say it goes up at a higher rate than that for 5,000. And that's what the graph looks like. So for taxable income, you know, in the previous piecewise functions, there was 2 dots here. But the way taxable income works is there's not just a magical jump in tax. They have to meet at the same place. Otherwise, someone earning $501 would end up with less money than someone who earned 500, which wouldn't make sense. So instead of having 2 different points you have to plug in boundary-wise, they'll always be on top of each other for something like tax. And that is all for 3.2.